Welcome back. I'm Miss Newroth, and tonight we will be talking about scales of analysis. What are you going to learn? Scale is a fundamental concept in geography. You will hear about it all year long, but sometimes it can be tricky. Earlier, you learned about map scale, the relationship of a distance on a map to the corresponding distance on the ground. Today, we are going to discuss scale in a different way. Scale as the size or scope of a phenomenon. We will practice identifying the scales of analysis presented by maps, quantitative and geospatial data, images, and landscapes. This is a skill that you will need to practice all throughout the year. Why is scale important? Scale can provide focus for research. A geographer may need to look at phenomena at a range of scales in order to draw conclusions. For example, imagine a geographer wants to research the impacts of a farming practice called intercropping in sub-Saharan Africa. This is a very large area, so how could the geographer focus their research? Well, the geographer may start at the local scale, perhaps doing some research in the Tanzanian province of Tabora, and then collect data across the country of Tanzania to be able to generalize about the practice at the regional scale. You see them going from the local scale to the country scale, and then being able to make some generalizations at the regional scale. The geographer would select the scale that is appropriate to address whatever specific research questions they may have. So again, why is scale so important? Well, geographers think about phenomenon ranging from the local scale to the global scale. The global scale is more important now than ever before because we have more sophisticated geospatial technology to understand how change in one place on Earth may affect change elsewhere. We also recognize that various scales interact with each other. For instance, the global economy may lead to specialization at a local scale. This is a concept you'll learn a lot about in Unit 7. A good example of this might be a local village in Tanzania changing their local economy to accommodate for many travelers, many from MDCs, that are coming to their local village to observe the wildlife or go on safari. The global impact of global tourism has caused that local village to make changes to their economy. So when we say scale of analysis, when we ask you to practice scale of analysis, what does that even mean? Well, first, scale determines the level at which we analyze geographic data. For example, we could analyze the scores of AP Human Geography students at many different scales. We could look at a global scale. Every AP Human Geography student in the world, we could analyze the data of their scores on that global level. We could zoom in to the country of the United States and just examine the data at that level. We could get more specific and look at it at the state level by looking at every AP Human student in Tennessee or in one particular county. We could zoom into every student at one school or even get extremely specific by looking at every AP Human Geography student in one class. Hopefully this gives you an idea of what we mean when we say scale of analysis. What level are we looking at the data? One of the ways you'll be asked to analyze scale or use scale of analysis is by looking at maps. So here we have a map that shows temperature and it is gathered at the global level. The data is global. However, this map can be helpful for doing regional analysis because I can look at South America, for instance, and I can see that the mean temperature there is above 44 degrees. So this global map can provide some valuable information that can be analyzed at that regional level. I have two additional maps here to give you an idea of how different information may be portrayed differently when you look at it at different scales. For example, the first map here shows the winning electoral votes in the 2016 election, blue for Democrats and red for Republicans. As you look at the United States and you look at the state of Arizona, for instance, you see that it is colored completely in red, indicating that it went for the Republicans, that the votes there went to the Republican nominee. You might, at that scale of analysis, make the assumption that everyone in Arizona voted Republican in that election. And that would be flawed analysis, because when we look at the second map, when we zoom into the state of Arizona, you'll see that there are several counties in the state that actually did have a majority of Democratic voters. That information is hidden when we simply look at the entire United States. So it's important to pay attention to the scale that you're looking at the data, because that scale can either hide or reveal different kinds of information. We also look at scale of analysis in quantitative and geospatial data. A good example of this is census data, something that geographers use all of the time. And I've got two different tables here to illustrate this concept of scale of analysis when we're looking at geospatial data. So in the first table, you see median household income for selected places. Now, if this were a test question, I might ask you, what kind of analysis does this table show, or what differences in the data do you notice in this table? And the answer I would be looking for is that you notice that there are different scales presented. The scale of the country, the United States, median household income, the scale of the state of California, and the scale of the county. So it's the same information presented at different scales. Now, in the second table, you'll see that it is median household income in selected counties in California. So all of the information in this table is presented at the same scale, at the county scale. And you can see that the data, the median household income, varies widely between the different counties. Now, if I go back up to the top table, I might be inclined to think, if I only look at the state of California, that most people in the state of California earn a median household income of roughly $71,000. When I go to the second table, however, I see that there is tremendous variation, ranging from roughly $45,000 in Modoc County to over $100,000 in San Francisco County. Similar to the data that we saw presented in the maps on the previous slide, it's really important to understand that when you gather information at one scale, say the state scale for California here, it's important not to draw conclusions about the local scale without actually having that local data. So that would be a fallacy in reasoning if we were to determine that most people in California make $70,000 when we realize, digging down deeper to the local scale, that there is tremendous variation. We also look at scale of analysis in images and landscapes. I have two images here, both showing the city of Las Vegas. Now, the first image shows only a few blocks, while the second image shows almost the entire city of Las Vegas. Now, images and landscapes can be incredibly helpful when we're analyzing a place. They can give us information about how a city is laid out, or you'll learn in the next unit a lot about the cultural landscape and what an image can tell us there. But it's important to note that images have limits. For instance, in the first image, if I were to ask you about the population density of Las Vegas, for instance, you wouldn't be able to tell that from that first image. So it's important to note that while images used at different scales can provide interesting information, you might get a better idea of the population density of Las Vegas by looking at the second image. They do have their limits, and that's important to keep in mind. Let's do a little bit of practice with these concepts. Which scale would be most effective if you were a town mayor trying to decide on the best location for a new traffic light? Well, if that were the case, you would pick the local scale of analysis. Which scale would be most effective if you were trying to compare life expectancy in Western Europe with life expectancy in Eastern Europe? That scale would be the regional scale. Which scale would you use if you were trying to figure out which state had the greatest need for funding based on population? In that case, it would be the national or country scale. Finally, which scale would you use if you wanted to analyze the territory size of Canada compared with Russia? That would be the global scale. What should you take away from this lesson today? Why is scale of analysis so important? If geographers are to solve problems, draw conclusions, they must use data at the appropriate scale and be comfortable moving between different scales to create and produce broader generalizations about what is happening in the world today. In the next video, we will discuss how patterns and processes at different scales reveal variations in and different interpretations of data. Thank you for joining me today. And welcome back. This is topic 1.6, Scales of Analysis. I'm Miss Neuroth. What are we going to be talking about today? Well, scales of analysis can be very powerful. In the last video, you learned about global, regional, national, and local scales. The scale that someone chooses to use to analyze data can inform, it can change, and it can influence the behaviors and decisions that people make. Geographers may look at different processes at different scales. They may analyze how those processes may work differently at various scales. So for example here, I once again have global down to local. So if I were a geographer studying how something like governance works at different scales, I might start with the global scale. Seeing the United Nations, for instance, that would be a global level of governance. At a national scale, we might have the United States federal government with the president. Getting down to a more local scale, we might have the state legislature or a governor. And then getting really close to home, getting very local, we may have something like a town mayor. A geographer may look at how governance functions differently depending on which scale they're looking at. Geographers are also going to be looking at patterns at various scales. They want to analyze different phenomena at those different scales to see if patterns remain the same or if they look different depending on which scale is used. So this pattern on the left here maintains the same pattern despite how big or small the place is. But in some cases, patterns may look different at different scales. Geographers are also interested in variations in data. So data at one level may tell a vastly different story than data at another level. This can lead to people drawing very contradictory conclusions based on what scale they're looking at. So for example, let's imagine that there is a disease that is spreading throughout the United States. Now, someone might look at the United States at a whole national scale and say, no, there's not very much spread of the disease. In fact, the trend is downward. There are less cases of this particular disease. Now, that may be true at a national scale, but perhaps if we zoomed in to a regional scale, maybe the region of the South is still struggling with that disease. Maybe it's still spreading in that part of the country. So for that region, the trend is going up, whereas for the entire country, the trend is actually going down. Now that could even be true of a local area. Perhaps this is a hot spot, for example, where there is a tremendous number of people spreading the disease. So the numbers for that area might be very critical. Whereas, again, if we go back to the national scale, there's a very low spread if we look at the entire country. Now, depending on which data someone looked at, it could cause them to draw very different conclusions about what's happening with the spread of that disease, for example. That would be an example of variations in data based on the scale that you look at that data from. This can also lead to different interpretations of data. So how one geographer, one person may see the information may be very different from how someone else sees the information, again, depending on the scale that they look at. This can lead to different conclusions. I have two maps of population. One shows population at a state scale, where the other shows population all of the way down to the county scale. So again, if we think about California, if I use the map in green, I might have a conclusion that the entire state of California throughout is heavily, heavily populated here. It's in the lightest color, meaning that there are the most people in that state, or a high portion of people in that state. But if I zoom in here and I'm perhaps trying to decide where resources should be distributed for human populations, this map right here on the right-hand side gives me a lot more specific information. I'm not going to spread those resources evenly throughout the state of California. Instead, I'm going to concentrate those resources on the places where I have the greatest amount of people. So one geographer may have one plan based on one map and the data therein, whereas another geographer may come up with a different plan or different conclusion based on using a different map. Let's take some time to practice this concept. This question states, which of the following sets of maps would help explain how scale of inquiry affects truth? A, maps showing the area of France before and after surveying. B, maps of Hudson Bay drawn by Native Americans and by the earliest European travelers. C, maps showing Michigan's population density by county and the United States population density by state. D, maps showing the number of auto thefts per block in Seattle in the decades before and after the Depression. E, maps of gang graffiti in Philadelphia. Now, if you're paying attention, there's only one of these answer options that really addresses the concept of scale. Many of them are comparing different things, but only one of them really highlights different levels of analysis. And that would be question or answer option C, maps showing Michigan's population density by counties and the United States population density by state, county being one level and state being the next. This can be illustrated with these two maps. In the map on the left, you'll see Michigan's population by county. You can see where that population is concentrated. In the map on the right, you see Michigan's population at the national level, just looking at how many people live in that state. But you're unable to see exactly where those people are. So this answer option discusses maps at two different scales of analysis. What should you take away from this lesson here today? Scales of analysis can be very powerful. The scale someone chooses to use to analyze data can inform policy decisions. It can change the way people understand risk during a pandemic. It can alter where a company decides to locate a factory, or even influence a politician's campaign strategy, among so many other important decisions. It's important to keep in mind that scale of analysis can alter the way people understand problems and also how they decide to come up with solutions. In the next video, you'll be exploring one specific scale of analysis, the regional scale. And as I always say, keep your eyes open because geography is everywhere.